Far out in space, a lonely celestial traveller continues its way through the outer reaches of the solar system. It's so far away that we can only see it as a weak point of light, so faint that even the largest telescopes and most sensitive cameras on Earth can barely catch it. Only 4 years earlier, it was the centre of attention of all the world's astronomers. With telescopes and spacecraft, they worked to unravel its secrets. It's a comet, the most famous of them all. It is Halley's Comet. It takes 76 years for Comet Halley to move around the Sun in its very elongated orbit. When it comes nearer, it develops a tail pointing away from the Sun. As the comet moves on, after the closest point of approach, its tail gets smaller and finally disappears. But let's start from the beginning. Already in 1976, 10 years before the predicted return in 1986, astronomers started to look for Halley with large telescopes. Who wouldn't like to be the first to see this famous comet again? At the European Southern Observatory on La Silla in the Atacama Desert, several telescopes participated in the search for Halley. Here is the first electronic image of Halley, made at ESO with a CCD camera. It's the very faint object at the centre of the circle. At this time, it was still 1,500 million kilometres away. 1 month later, Halley was somewhat brighter. And after another year, it had brightened considerably. But there was still no sign of a tail. So when and how did Comet Halley finally acquire a tail? Let's have a closer look. At the centre of all comets, there's a solid body which we call the nucleus. Here is a simplified drawing of a cometary nucleus. It's like a dirty snowball, but it measures 15 kilometres across. It mainly consists of frozen water ice mixed with solid particles of all sizes, from dust and sand to small stones and boulders. When this dirty snowball comes closer to the Sun, the sunlight becomes more intense and the temperature on the surface increases. The snow and ice begin to evaporate. A cloud of molecules and dust is formed around the nucleus. With time, the fog becomes increasingly dense. Soon, it will hide the snowball in the middle. The cloud grows. The sunlight is reflected in the dust and the comet gets brighter and brighter. We call this cloud the comet's coma. As the comet comes closer to the Sun, the intense sunlight pushes the molecules and the dust in the direction away from the Sun. The sunlight heats the coma and the temperature rises all the time. The Sun's ultraviolet light breaks down the molecules in the coma. Some of the molecules and atoms are electrically charged. They interact with the so-called solar wind, that is, fast particles emitted by the Sun. A long, straight ion tail is then formed, which points away from the Sun. When the ice and snow evaporate from the nucleus, the dust grains fall out. As the comet moves, they are left behind and form a broad, curved dust tail. It shines because of reflected sunlight. But the ion tail glows by itself, because its molecules and atoms are very energetic. Here is the first ion tail of Comet Halley. There were several such tails at the same time. We are now about to see one of the most remarkable sequences ever obtained of a comet's ion tail. A very sensitive wide-field camera was installed at La Silla in February 1986, just after Comet Halley had passed the point closest to the Sun. For 2.5 months, many exposures were made every night of Comet Halley's ion tail. More than 800 pictures were taken to document the changes in unsurpassed detail. The camera registered the light from carbon monoxide ions in the tail. The time of exposure is shown in the lower right-hand corner. This project was directed by ESO astronomer Holger Pedersen, who also computer-processed the pictures for scientific study. Here we go. We can see how the tail changes, and the outward motion is very obvious. If we watch carefully, we can also see big blobs in the tail that sometimes move outwards. Sometimes the tail bends and twists. This is when Halley passes through regions in interplanetary space where the magnetic field is disturbed. This field interacts with the electrically charged ions in the tail. Some of the images are overexposed because the Moon interfered in the second half of April. We have now seen the development of Halley's ion tail over 2.5 months in just 1 minute. We now repeat the entire sequence at half the speed for greater clarity. The spacecraft Giotto passed Halley on March the 14th. Here we have another disturbance in the tail. The jumping bright spots have nothing to do with Halley, however. They're reflections in the camera from bright stars. Now, a blob in the tail is moving outwards. It's a concentration of carbon monoxide ions, which is pushed away by action of the energetic particles in the solar wind and the associated magnetic field. We see a lot of activity in early April. Large parts of the ion tail are ripped off. By studying the motion, it's possible to measure the strength and direction of the magnetic field in interplanetary space. On April the 11th, Comet Halley was closest to the Earth. Some days later, Halley passes a magnetic boundary in space. There, the direction of the magnetic field reverses. This is recorded by the fast motion in the tail. It bends and twists and also shifts sideways. On May the 1st, a condensation was observed in the tail for the last time. In early May, the brightness of Comet Halley decreases. The orbital motion carries it towards the Milky Way band, and there are noticeably more stars in the field. The ion tail fades until it's hardly visible anymore. This is the control room, where the images were recorded. The film was made on the 4th of March, when a big condensation was discovered in the tail just 1 day before the first of a total of 5 spacecraft flew past Halley. The images we have just seen are of great scientific value for the study of Halley's tail and the interplanetary magnetic field. That is particularly true of the most dramatic events. On several days in March, moving condensations were seen. Also in early April. And even as late as May the 1st. There was a lot of activity in the tail on April the 8th and 9th. The same condensation could be followed on consecutive nights. The tail had a peculiar wavy form on April the 11th, and also for some days in early March. The wide field camera was also used to obtain images of Comet Halley's broad dust tail in red light. When it was first observed in late February, it looked as if Comet Halley had several dust tails. This is because the dust was released from the nucleus in a very uneven way. Sometimes, great amounts of dust emanated in a very short time. We can read the history of these outbursts from the shape of the dust tails as we read tree rings. They tell us what happened when Halley was nearest the Sun. Images of the dust and ion tails were also obtained with the ESO-Schmidt telescope. This telescope is much bigger than the wide-field camera, so the Schmidt photos show more details. However, they cover a much smaller sky field and do not show all of the tail. As Halley moved away, it crossed the Milky Way and the tail slowly faded. Here is a false colour photo taken 2 years later. The nucleus is at the centre. At this time, Halley was just outside the orbit of Saturn. It still has a very large coma of dust, proving that dust grains continue to come off the nucleus as Halley moves out through the solar system. 1 year later, Halley has moved another 300 million kilometres further away from the Sun. This is a picture obtained with the Danish telescope at La Silla. It's not so easy to see the comet, so let's improve the picture by means of computerized image processing. First, we eliminate most of the artifacts introduced by the camera. Now the background looks smoother. Then, the star images in the field are removed by the computer. Now the comet is somewhat easier to see. Next we add about 30 such images with a total exposure time of more than 15 hours to see the detailed structure. It's clear that Halley still has a big coma. The computer further enhances the structure of the coma, and we now see that Halley has a short tail that points upwards. It's a jet of dust streaming out of the nucleus, but it's much smaller than the gigantic tails 3 years before. And this is what was observed 1 year later. Now there is no coma left. We see only the sunlight reflected from the nucleus. Halley's dirty snowball is again frozen stiff. Halley's comet was born 5,000 million years ago in the same interstellar cloud of dust and ice from which the Sun and the Earth emerged. But while the Earth has undergone great changes, Halley still contains unchanged original matter from the earliest epochs of the solar system. The study of comets is vital for understanding our own distant past. Comet Halley will be back in the year 2061. By then, some of today's children will have become tomorrow's astronomers. With the public, they'll again receive this famous celestial visitor and observe its beautiful tail. And maybe they will then have a look at this old film to remember how Halley behaved in 1986.